You ever wondered, if the universe suddenly sent us a letter, what would it look like? And could we, even with all our smarts, be able to read it? Well, buckle up, because a letter like that has just zipped past our solar system, and it's no fairy tale. It's not a star, and it's not a planet. It's 3I Atlas. The name might sound a bit dry, but the yarn behind it is full of drama, mystery, and it could flip our entire book on the cosmos on its head. It's a lone wanderer who's crossed billions of light years just to cruise past our backyard. An interstellar visitor that's shaking up the science world and maybe our whole understanding of what we call home. But the real question isn't what is it, but why has it come to visit us? Mate, have you ever stopped to think, is this whole big universe just some simple machine running on rules we've already got sorted out in a textbook? Well, 3I Atlas is here to properly challenge that idea. It's not just a comet, it's a key that could unlock doors that have been locked for billions of years. An interstellar visitor, or a piece of cosmic history, the clash of science and the wildest theory ever. We're talking about a strange visitor, a lone drifter. But the biggest question is still floating around out there in space. Where's it from? In the vast universe, a rogue celestial body like 3I Atlas showing up in our solar system is like a message in a bottle tossed into the cosmic ocean. But this message didn't come from our neighbours. Its orbit, a perfectly hyperbolic curve, says it all. It isn't bound by the sun. It doesn't belong to us. It's crossed a boundary. It's broken all the rules. This has absolutely rocked the world of astronomy for all of humanity. If you're a space explorer, you'll realize this isn't just a comet, it's a living message. To decode this message, we have to track down its origin. We have to find its mum and dad. And this is where we get into a thrilling game of scientific deduction, turning every textbook on its head. Scientists all around the world have aimed their telescopes and computers at 3I Atlas. They're not just looking at the present, they're looking at the distant past, billions of years ago. By analysing its trajectory, they can wind back the clock to see where it went before it found us. It's an intergalactic hunt for clues. You know, the universe isn't a peaceful place. Galaxies smash into each other, stars kick the bucket and hurl their bits and pieces into the great wide open. 3I Atlas could be one of those fragments. One of the first and most fascinating theories is that it came from a dwarf galaxy that was swallowed by our very own Milky Way. Imagine, our Milky Way is like a cosmic behemoth. Over billions of years, it has gobbled up smaller dwarf galaxies, absorbing their stars, gas, dust, and little objects. 3I Atlas could be one of the remnants left over from a feast like that. It's like a lone survivor, a witness to a cosmic event that happened eons ago. But what if it didn't come from a dead galaxy? The second theory, no less compelling, is that 3I Atlas came from a different solar system, but not a planetary system like ours. It could have been born in a much more extreme environment. Imagine a binary star system, where two stars are dancing a waltz of death around each other. Their gravitational pull is incredibly complex and powerful. A small object, like a comet, if caught between these two stars, could be flung out of its system at an insane velocity, breaking free from all gravitational limits. 3I Atlas could be a cosmic bullet fired from a star system like that. Then there's another possibility, equally speculative and imagination-stirring. 3I Atlas was born from a giant molecular cloud. These are the nurseries of stars, where cosmic gas and dust gather, gradually collapsing under their own gravity to create new stars. However, not all of the material in there becomes a star. Some can be kicked out during the star formation process, becoming a wandering object like 3I Atlas. This means it's a leftover fragment of a baby star, a witness to the birth of a star. So, we're left with a big question. Is 3I Atlas a survivor of a dead galaxy, a bullet from a binary star system, or an abandoned child from a molecular cloud? But why do we even care about this story so much? Because by tracing the origins of 3I Atlas, we are not just deciphering one celestial object. We are deciphering the very history of the Milky Way, the history of dead stars and galaxies. It's a clue, a collection of precious materials formed and existing in an environment completely different from our own solar system. This isn't just about finding a home for a comet, but about unraveling a piece of the cosmic tapestry that we've never been able to witness. It's a shard of an old story, sent here to teach us a new lesson. And that lesson could change everything.
Scientists are currently zeroing in on analyzing the spectrum of 3I Atlas to hunt for distinct chemical signatures. They're searching for elements, rare isotopes that can only be forged in the most extreme environments, like within a dwarf galaxy or a binary star system. If they find these signatures, it'll be the smoking gun to pinpoint the parents of 3I Atlas. This is a race against time. As it gets closer to the Sun and as it moves away, that data will become clearer than ever before. We, the science buffs, have a front row seat to one of the greatest discoveries of the 21st century. So, is 3I Atlas a survivor, or just a speck of dust in a cosmic storm? Whatever the answer is, it's still telling a story of life, of death, of a solitary journey through the cosmos. Let's listen together. The ice mystery and the shocking difference. If we consider 3I Atlas a strange visitor, then what it's brought along in its luggage is even weirder than the comet itself. When our most powerful telescopes, from James Webb to SPH-REX, turned their gaze towards it, we discovered a shocking truth. This comet, from an immense distance, is emitting a kind of mist, a halo that surrounds it. But that's no ordinary dust or water vapor. It's carbon dioxide mist. Imagine a giant block of dry ice, bigger than an entire city. As it travels into a warmer part of space, it doesn't melt into water, but sublimes directly into a cloud of cold gas. That's what we're witnessing. And this is completely unusual. Comets in our solar system are mostly powered by water vapor. We might see a bit of carbon monoxide, but carbon dioxide is the key player here. According to data from scientists, the amount of CO2 escaping from 3I Atlas is 16 times more than the amount of water. This is an enormous difference, an undeniable sign that it wasn't born here, in our cosmic neighborhood. So what does this mean? It's like opening an old fridge door and instead of seeing ice, you find a massive block of dry ice. Right, a block of dry ice, a type of ice that only forms at extremely low temperatures, below minus 78.5 degrees Celsius, a temperature that can only exist in the most distant frigid regions of space. The abundance of CO2 in 3I Atlas shows it was born and existed in an ultra-cold environment, possibly in regions far beyond the CO2 frost line of its parent star system. By analyzing what it's spewing out, we're reading its travel journal.
But the story doesn't stop there. Besides CO2, scientists also found water inside 3I Atlas. But this isn't just any old water. This could be ancient water, water molecules perfectly preserved from the very beginning of the universe. Picture the dust and gas in a molecular cloud that creates stars and planets. We reckon these particles are covered in a layer of icy cold water. This water, when a comet forms, gets locked inside it, and when the comet comes to our solar system, it melts, releasing that water. However, if 3I Atlas came from a star system older than ours, then its water particles might have formed in a totally different chemical environment, maybe even in the early days of the Milky Way. What we're looking for is the isotope ratio of the water. The ratio of heavy hydrogen, deuterium, to regular hydrogen, protium, in 3I Atlas's water could be a crucial clue. This ratio is a star's fingerprint. It tells us about the environment the water was created in. If this ratio is different from the water on Earth, or the water on other comets in our solar system, then we can conclude that this water was made in another star system from a completely new environment. This will help us get a better handle on how planetary systems are formed across the galaxy. It's like finding a vintage bottle of wine, but the label shows a type of grape that's never existed on Earth. Tasting that grape doesn't just tell you its flavour, it tells you the story of the soil, the climate, the culture where it was made. 3I Atlas is that bottle of wine of the universe. It's carrying a type of grape that was never grown in our solar system, and it'll tell us the story of its own origins. And finally, what's kept 3I Atlas intact for billions of years? Why didn't it fall to bits on its journey? The answer might be in the presence of ancient ice. Scientists believe that 3I Atlas is one of the oldest comets ever seen. It came from a dense region of the Milky Way where stars and planetary systems have been forming for ages. The ice inside it was compressed, going through geological and chemical changes over millions of years, making it much tougher and more stable than the ice of the younger comets in our solar system. This explains why it's still in one piece after travelling such an epic distance. Studying this ancient ice doesn't just help us understand 3I Atlas, it also gives us a deep dive into how primordial matter is preserved in the cosmos. It's like archaeologists finding a fossil of a never-before-seen creature, perfectly preserved in a chunk of ice. That fossil doesn't just tell us about the creature, it tells us about its habitat, the ecosystem, the changes of an entire planet. 3I Atlas is that fossil of a dead star system, a remaining puzzle piece of a massive picture. The discovery of CO2, water and ancient ice on 3I Atlas isn't just a scientific find, it's a magic moment, a whisper from the universe's distant past, inviting us to look a bit deeper. It's asking questions we'd never even thought of, and it might just change how we see ourselves and our place in this massive universe. So remember this, mates, when a strange object shows up, it's not just a mystery, it's a key.
Rare isotopes and cosmic origins. 3I Atlas challenges the foundational theory of stars. When we look up at the night sky, we often think of stars as these giant cosmic factories churning out the elements that make up the universe. For billions of years, we've believed that everything from the hydrogen floating in space to the iron in our blood was cooked deep in the hearts of stars. That's the theory of stellar nucleosynthesis, one of the cornerstones of modern cosmology. It's a yarn about how the universe built itself from the ground up, eh? But what if, one day, a guest from a faraway place, a complete stranger from outside our very own Milky Way, brought along some fair dinkum evidence that this story was missing a few crucial chapters, eh? Well, that's exactly the story of 3I Atlas. We've already had a chinwag about its solitary journey, about the mystery of its CO2 ice and ancient water. But there's something heaps more fascinating and absolutely mind-boggling. What's lying deep inside its core, those rare isotopes that could completely flip the whole theory of how stars are created right on its head, eh? The isotope revelation, a cosmic gift or a trick. To get your head around this shock, we just need to take a quick squiz at how stars work. A star's like a cosmic furnace, fair dinkum. It takes hydrogen, melts it down under bonkers pressure and heat to create helium. This process keeps on going, creating heavier elements like carbon, oxygen, and finally iron. What about the even heavier stuff? They're crafted in one final explosive, creative moment, a supernova explosion. That's when a massive star carks it, releasing energy and matter with unimaginable intensity, creating gold, uranium, and other rare elements, scattering them right across the cosmos. That's the theory. But 3I Atlas is carrying isotopes that scientists have never ever seen in any celestial body that formed inside our own solar system. Isotopes are basically different versions of the same element with a different number of neutrons. For example, carbon-12 is the common isotope, but carbon-14 is the rare radioactive one.
So what isotopes is 3I Atlas carrying? The first hypothesis, based on a preliminary spectral analysis, is that it contains a significant amount of some uncommon lithium, beryllium, and boron isotopes. According to current theory, these elements are incredibly difficult to find in the core of a star, as they'd be instantly destroyed. We believe they're created in cosmic rays, when high-energy particles smash into lighter elements. But 3I Atlas contains a huge amount of these isotopes. This raises a chilling question. Is there some element synthesis process we've never known about? Another cosmic forge that isn't a star's core or a supernova? This could point to an astonishing possibility. 3I Atlas was born in a completely different environment, possibly a dwarf galaxy, where the conditions of pressure, temperature, and matter composition are entirely different from the star-forming regions in our own Milky Way. This means that the story of the origin of heavy elements might not just revolve around massive stars and supernovas. There could be another player, some mysterious process that occurred in the most distant reaches of the universe, where our theories have never reached. Old textbooks and the universe's red pen. Imagine a university professor standing in front of a class, explaining the theory of nucleosynthesis. He writes the formulas on the board, draws a star diagram, everything is coherent and logical. And then 3I Atlas appears, carrying a giant red pen and drawing a line straight through it all. The existence of these rare isotopes in 3I Atlas directly challenges what we call primary star theory. This theory describes how the very first stars formed from primordial matter after the Big Bang. According to it, they only contained hydrogen and helium. It was only much later that subsequent generations of stars became rich in heavier elements. But what if 3I Atlas came from a star system that already had a large amount of rare elements from a very early stage? This could point to a completely different star formation process, or even a different version of the early universe, where elements were created in some event we've never known about. It's like we're reading a history book and suddenly discover a crucial historical figure has been left out. This person could have changed the entire course of history, and we are standing before a living proof of that existence. 3I Atlas is that proof. It's not just a block of ice, it's a time capsule holding the secrets of the very origin of the universe itself. You know what they say, when the universe sends a message, it doesn't use language, it uses secrets buried in rock and ice.
hottest science news and phenomena of 2025. Scientists around the world are absolutely buzzing. Every major space telescope, from the James Webb Space Telescope to ground-based observatories in Australia and Chile, is locked on to 3I Atlas. This is the hottest science story of 2025. Scientific papers are dropping left, right and centre, and online conferences are happening non-stop. Why? Because 3I Atlas offers an unprecedented chance to re-examine our most fundamental assumptions. We can analyse its chemical composition, look for ultra-rare isotopes, and compare them to theoretical models. If these isotopes don't line up with what we predicted, what do we do then? We go back to the drawing board. For Australian audiences, this is an especially captivating yarn. With some of the world's leading astronomical observatories right in their own backyard, like Siding Spring Observatory, they're at the very forefront of this scientific revolution. They're not just spectators, they're part of the story. And that's what makes science come alive. This jolt isn't just a number, a formula, it's an adventure. It's a reminder that we have so much to learn, and the universe's biggest secrets could be flying right past us, just waiting to be cracked. The future of cosmology, a collision of theory and evidence. So where does this story go from here? 3I Atlas might not be a technological probe, but it could be a message from the cosmos in a different way. It's living proof that the universe is bigger than we ever thought, and its diversity goes way beyond the limits of our imagination. If 3I Atlas truly is carrying rare isotopes, it'll open up a whole new field of study: interstellar chemical astronomy. We'll have to build new models to explain how these wandering celestial bodies form. We'll have to look at dwarf galaxies, globular clusters, and places we once thought were lifeless to find the answers. The story of 3I Atlas isn't just about a comet. It's about human humility. It reminds us that, despite all our incredible progress, we're still only at the very beginning of our journey to explore the cosmos. And this right here is when we need to get ready for the next surprise. Because the universe never stops sending us letters, and each one could change everything we thought we knew. 3I Atlas, an interstellar treasure chest and a materials revolution on the horizon. Have you ever picked up a pebble on the beach? What do you see when you look at it? Just a normal rock, right? It was formed over millions of years of wind and water erosion, or thousands of years under the pressure of a volcano. That's the story of the rocks on our Earth. But today, we're going to tell a different story. A story about rocks that travel between the stars. This story starts with 3I Atlas, a comet that isn't just a lump of ice and rock drifting around. It's a fragment from a distant galaxy, a visitor carrying treasures we've never seen before. And the biggest question we're facing is, if 3I Atlas is carrying interstellar minerals, materials that have never appeared on Earth, how will that change our world as we know it? Picture this. Every mineral on Earth follows our own specific laws of physics and chemistry. From diamonds formed under the extreme pressure of the Earth's crust to quartz crystals in caves, they were all created in a factory with very specific conditions. But the universe is different. Out in space, anything is possible. A star can explode, releasing millions of times more energy than our sun. The pressure of a black hole can warp space and time. In those extreme conditions, entirely new material structures can be created. Atoms can combine in ways we've never even thought of. That's exactly what we call interstellar minerals. They're not rocks in the usual sense. They are recipes written by the universe itself. If we can study these minerals, it will open up a new era. Flipping the materials science script from the lab to the cosmos. Now this is where things get properly cooked.
If 3i Atlas is carrying some exotic materials, it'll have a direct crack at the material science game. Have a think about these possibilities. Super durable, feather-light materials. Could there be elements or molecular structures arranged in a way that's totally different, creating a material that's tougher than diamond but lighter than a feather? A kind of alloy born from a supernova could stand up to any pressure or temperature we can chuck at it on Earth. A material like that would be a total game changer for everything from making spaceships, cars, and airplanes to even micro-sized electronic gadgets. Superconductive materials for heat and electricity. Scientists have spent their whole lives looking for materials that can superconduct at room temperature. But the cosmos, well, it's a massive lab where bonkers conditions could create those materials naturally. If 3i Atlas is lugging even a tiny bit of a superconductive mineral, we'd have a crack at studying it and even replicating it. Self-healing materials. This sounds completely off its head, but if an interstellar mineral has a special structure, it could rearrange its molecules after being damaged, a bit like how the cells in our bodies can repair themselves. Materials like that would absolutely change the whole show for the construction, medical, and manufacturing industries. Think robots that can fix themselves, or medical materials that can literally heal a patient's wounds. However, its importance isn't just about what happens in a lab. The minerals on 3i Atlas are a living history book, telling the tale of the universe's origins. The signature of primordial stars. These minerals could have formed from the first generation of stars, stars that died billions of years ago. By analyzing their composition, we can uncover the chemical elements and material structures that existed at the dawn of the cosmos. This will help us answer questions like, were the first stars made of different elements than our sun? Was planet formation in other galaxies similar to what happened in our solar system? The secret of matter distribution. 3i Atlas is proof that matter can travel between galaxies. This means that chemical elements and complex compounds could be seeded from one galaxy to another. It opens a brand new door for the theory of life. Could the building blocks of life be transported from place to place across the universe? You see, 3i Atlas isn't just a comet. It's a test, an adventure, and it could be an invitation from the cosmos. An invitation for us to learn, to expand our horizons, to realize that what we've written in textbooks is just one small chapter in a massive book. We're on the cusp of a great discovery, a historical moment that could change the way we see ourselves and our place in the universe. Remember, sometimes the greatest thing isn't the answer, but the questions we learn to ask. 3i Atlas has brought us so many questions, and now we have to be brave and find the answers.
Heavenly body or machine? Imagine one night, as you're sound asleep, a flash of light streaks across the night sky. You jolt awake, thinking it's a shooting star, but no, it's brighter, faster, and it has an unusual trajectory. That's exactly what scientists felt when they discovered 3i Atlas. And right here, within our grasp, a cosmic mystery is waiting to be unraveled. For years, we've been tracking objects flying through the solar system. Most are just wandering rocks, precious gems from the early days of the universe. But 3i Atlas isn't like anything we've ever seen. It has a weird orbit, an extraordinary speed, and most importantly, it has an unusual brightness. This very anomaly has sparked a fierce scientific debate. Is it a natural celestial body or a machine crafted by aliens? Science challenges the hypothesis.
celestial body model versus technological model. To answer this question, astronomers have thrown themselves into a large-scale investigation, making 3I Atlas one of the hottest topics of 2025. The celestial body model. Scientists in this camp argue that 3I Atlas is a natural celestial body, possibly a comet or an asteroid. The comet hypothesis. They believe its unusual brightness is due to a large amount of volatile ice which heats up as it gets closer to the sun, creating a huge mane of gas and dust. The asteroid hypothesis. Some other scientists reckon it's an asteroid, possibly with a heavy metal composition that reflects sunlight strongly. But if it's that simple, why does it have such a bizarre orbit? That's the fatal flaw of this model. To explain that anomalous trajectory, they have to assume it once collided with another celestial body, changing its direction of flight. The technology model. Now this is a bold hypothesis, but it's a super compelling one for anyone craving a sign of extraterrestrial life. They reckon 3I Atlas is an artificial object, maybe a scout ship, or an automated probe. Nuclear energy. The scientists backing this theory say its brightness isn't just reflected sunlight, but rather from an internal power source, potentially nuclear energy. The unusual orbit. This unnatural trajectory might be because it's actively course-correcting, not just from a collision or natural gravitational forces. In this debate, no one's really got the upper hand. Each model has its own pros and cons, but this very disagreement is what's pushed scientists to work harder than ever to get to the bottom of the matter.
Could 3I Atlas really be using nuclear power? This is an absolutely huge question, because if the answer is yes, we're facing a mind-blowing truth. The celestial energy model. Under this model, 3I Atlas's energy comes entirely from the sun. Its power? Solar energy heats the ice, turns it into vapor, and creates the brightness. Its power depends on how far it is from the sun. The closer it gets, the greater the power, and the brighter it shines. How it glows? Its light is either a reflection of sunlight or from the dust and gas glowing on its own. The technology model, nuclear energy. In contrast to the celestial energy model, this one suggests that 3I Atlas has an independent energy source. Its power, an object using nuclear energy, can create a massive amount of power. If 3I Atlas truly is a spacecraft, it could use nuclear energy to keep itself going for a super long time, maybe even for millions of years. How it glows? Its brightness could come from a small fusion reaction, just like our own sun, or a controlled fission reaction. We need to do a scientific experiment to prove this. We could analyze the light spectrum of 3I Atlas. If it's a celestial body, the spectrum would show typical comet and asteroid elements, like carbon, oxygen, and hydrogen. If it's an alien machine, the spectrum could show traces of heavier elements, like uranium or plutonium, or even some weird elements we've never seen on Earth before. This isn't just a science experiment, it's also a search for the truth, a journey to uncover the deepest secrets of the universe.
Hypothetically, if 3I Atlas is a technology, the challenges, risks, and opportunities for humanity. If 3I Atlas truly is an extraterrestrial object, then this isn't just a scientific discovery, but a historic moment. It would completely transform how we see our place in the universe. The challenges. Cultural. We'd have to face the truth that we're not alone. This could spark a major cultural and religious crisis. Scientific. We'd have to understand their technology. Are we advanced enough to crack their code? Or can we leverage it to develop our own tech? Political. Contact with another civilization could cause serious political and social conflicts. Could nations work together to tackle a common challenge, or would they use this as an excuse to get one up on each other? The risks. Latent dangers. We simply wouldn't know their intentions. Are they friendly, or are they a threat? Technological risks. If we can't figure out their technology, it could fall into the wrong hands and lead to unimaginable catastrophes. The opportunities. Scientific advancement. If we can learn from their tech, we could make massive leaps in science, technology, and medicine. We could solve humanity's most pressing issues, like climate change, energy, and disease. A shift in mindset. Contact with another civilization could help us change our way of thinking, move past our conflicts, and work together to build a better future for humanity. Expanding our horizons. It would show us that the universe is a vast and mysterious place, and we're just a tiny part of it. And so, we're at a historical crossroads. On one side is a natural scientific hypothesis, and on the other is a bold yet promising one. Whatever the outcome, this search will change us forever. How will this cosmic adventure continue? Will the mystery of 3I Atlas be solved?
A forecast on 3I Atlas, a mind-blowing flyby, a revelation from deep space. Can you feel your heart pounding in your chest? That feeling right there is all of humanity's excitement over a nomad from the far-flung stars. 3I Atlas, an uninvited guest, is on a journey through our solar system, carrying with it an ancient story that no one has ever told before. This journey isn't just an astronomical event, but also a fated rendezvous, a cosmic call that the universe is making to us. When will we lose sight of it, and when will we meet again? This period, September 2025, 3I Atlas can still be observed with large ground-based telescopes, but in just a few weeks it'll duck behind the sun's blinding glare, and we'll have to say goodbye to it with a heavy heart. During this time, from late September to the end of October, it will be almost impossible to see from Earth. It's a proper cliffhanger, creating a huge amount of curiosity and a massive urge to explore. But after the night, the dawn always shines bright. The forecast suggests that 3I Atlas will reappear in early December 2025. This is when we'll get to catch up with it again, a meaningful reunion. This time, it'll be in a more favorable position for scientists on Earth and in space to continue their work. Golden opportunity for research. Counting down to October and December. October isn't the golden time for observation from Earth, but it's the month for top-notch discoveries from the eyes on Mars. As 3I Atlas approaches the Sun, it'll also fly right past our red neighbor. The European Space Agency, ESA, spacecraft like Mars Express and the ExoMars Trace Gas Orbiter will seize this golden opportunity to observe the comet from a completely fresh angle. This promises to deliver data with even higher resolution than the Hubble Space Telescope. A surprise rendezvous between a stranger and a local. Will Mars be able to have a yarn with 3I Atlas? The hunt will hit its peak in December. After passing its perihelion in late October, 3I Atlas will begin its journey out of the solar system, and that's exactly when it'll return to being our best view. It will be brighter, more active, and allow both ground-based and space telescopes to have a proper sticky bike. This is a rare chance for us to grab some valuable information before it forever disappears into the vast expanse of space. What will it reveal at perihelion? When 3I Atlas reaches perihelion,
That is, its closest position to the Sun, what's going to happen? It'll be cooked to the max, releasing a huge amount of material, creating a brilliant tail and coma. This is when it's most active, and also when it's most likely to break up into multiple pieces. All eyes in the astronomical community are glued to this moment, with one big question: will it survive? Will it reveal any secrets about the makeup of a celestial body from another star system? Scientists are hoping to score some unprecedented data from the observation devices on Mars and from our most powerful telescopes. The spectroscopic senses will try to read its chemical composition, looking for signs of water, carbon dioxide, or organic compounds. This won't just help us get a better handle on 3I Atlas, but will also give us clues about the planet-forming environment in those faraway places in the Milky Way.
Future observations, what's still unknown, and what we'll soon know. The future of observing 3I Atlas will focus on making the most of humanity's most advanced observational technologies. We won't just be relying on Hubble and Webb, but also on other eyes floating around in space. Space observatories. Telescopes like Hubble, Webb, and Gemini will play a key role, especially in analyzing spectral data and imaging. James Webb, with its infrared capabilities, could potentially find signs of ice and organic compounds hidden deep inside. Planetary probes. Beyond Mars Express, other missions like ESA's JUICE could also get a look in, grabbing the opportunity to observe 3I Atlas from some truly unique angles. Ground-based observatories. While they can't observe it when it's close to the Sun, telescopes like the Vera C. Rubin in Chile, with its all-sky scanning ability, will help us track its path as it starts to head off, giving us more time to study it. Studying 3I Atlas isn't just about a comet, but about whether we're ready to receive these letters from the cosmos. This is a golden opportunity to explore a piece of the puzzle from a completely alien star system, a valuable lesson on the formation of planets and life somewhere out there. With every step we take, we get closer to the universe's greatest mysteries, and the journey of 3I Atlas is one of the most exciting chapters in that story. Risky probe. Is it possible to send a probe to 3I Atlas for a sample? Some visitors have come from a distant place, a place where the light of the sun is but a tiny dot. They appear like ghosts sweeping through the solar system, carrying with them the secrets of worlds we've never known. We've met two of them. Oumuamua, a cigar-shaped object, moving at an unbelievable speed and disappearing as quickly as it appeared. It stunned the scientific community, sparking speculative theories about an artificial origin. Could it have been a discarded probe? Then there was 2I Borisov, a more normal comet, yet one of the most definitive proofs that interstellar objects exist. It carried the chemical traces of another world, a silent message from the vast universe. We missed them both, but the universe once again has sent us a third chance. And now we have 3I Atlas, another interstellar comet discovered in 2025. It's not like the bizarre Oumuamua, nor is it exactly like 2I Borisov. It's a mix of both, carrying a completely open orbit, not bound by the sun's gravity. 3I Atlas will only fly by once, then disappear from our sight forever. This isn't just an opportunity, it's a challenge, a real-life race against the clock. Just imagine you're on a train moving at 100 kilometers per hour, and now you want to launch an unmanned drone to chase another car moving at 200 kilometers per hour on an unknown road. That's the situation space scientists are now facing. The challenge, a nasty conundrum. To catch up with 3I Atlas, we need a spaceship with insane speed. Our current probes like Voyager or New Horizons, while super quick, are still way too slow. The interstellar comet is moving at a speed that's well beyond the sun's escape velocity. This is a physics problem. We can't just simply launch a craft after it. We need more propulsion, a smarter plan, and a little bit of a reckless streak too. Is it possible to create an engine with this capability? Yes, but those ideas are still in the early stages. Let's look at what we've got in our toolkit. Ion thrusters. These provide a small but constant push, which helps a craft gradually build up high speeds over time. But is it fast enough to catch up with 3I Atlas? Interstellar propulsion? This is an old idea that's getting a second wind. It uses energy from nuclear reactions to heat a propellant, creating a massive thrust. NASA and the US Department of Defense are actively researching this tech. Gravity slingshot technique? Using the gravity of gas giants like Jupiter or Saturn to accelerate a spacecraft. A powerful kick to get our craft on the right trajectory. All of these technologies still need time to get polished. Can we pull it off before 3I Atlas disappears into the void? So, how will humanity tackle this? The answer is a combo of existing tech and some bold ideas. Phase 1, the Quick Reaction Flyby mission. This is our most feasible option in the near future. A go-for-broke mission with no time for perfection. The goal: launch a small spacecraft using the most advanced propulsion tech currently available to fly past 3I Atlas at the closest possible distance. The gear? The craft will only carry minimal gear. A high-resolution camera for photos, a spectrometer to analyze the chemical composition of gas and dust, and a small sample collector. The catch? We will only have a few seconds or a few minutes to collect the data. It's like taking a photo of a lightning strike. You can see it, but you can't fully grasp its power. Phase 2, the Pioneer Mission, Rendezvous. This is an ambitious plan. It could be humanity's first interstellar exploration mission. Objective: launch a spacecraft to catch up with and accompany 3I Atlas for a prolonged period, studying it in intricate detail and collecting samples. Core technology: nuclear-powered ion propulsion, a combination of powerful initial nuclear propulsion and energy-efficient ion thrusters to maintain speed. The suicide sample collection technique. A robotic arm will be launched to collide and collect a small amount of the comet's material, then return it to the mothership's containment bay. Risks? This is an incredibly risky mission. A minor miscalculation in the orbital trajectory could send our ship adrift in the boundless void. So why are we taking such a gamble? Why throw billions of dollars and extraordinary efforts at chasing a dirty snowball from deep space? Because it's not just a regular snowball. It's a time capsule from another world. It could hold the answers to our biggest questions. How did life form? How vast is the universe out there? Are there other worlds just like ours? Every speck of dust, every gas molecule on 3I Atlas is a piece of the cosmic puzzle. This mission isn't just about science, it's about the human spirit. It's the yearning to push beyond our limits, to venture into the unknown, to prove that we, these tiny beings on a blue planet, have the courage to reach for the stars. Whether we succeed or fail, this race has already begun, and it will forever shape the future of human space exploration. 3I Atlas isn't just a comet.
It's a mirror reflecting our curiosity, a reminder that the universe isn't just a bunch of formulas, but a treasure trove of untold stories. It challenges us. It pushes us to go beyond our own limits. This is the moment we have to accept the truth. The universe is so much bigger than we ever imagined, that the story of our origins could be rewritten by a strange visitor from a distant galaxy. Remember, every great story begins with a small question, and with 3i Atlas, that question could be, where do we go from here? If your heart just had a little flutter, if your brain just got fired up by a cosmic story like this one, then that's a sign you've found your home. Space Plus isn't just a place to tell stories, it's a place where we explore together, get a little mad together, and rewrite the textbooks together. So, don't hold back. Hit that subscribe button and turn on notifications so you don't miss out on another story. Because here, we don't just watch the universe, we live it. Leave a question or your thoughts on 3i Atlas in the comments section. We want to hear your story. Space Plus, where science goes beyond formulas to tell soulful stories.